All right, today we got a 2018 F-150 with the 5.0, and we're going to be reviewing the PCV systems. This is a pretty famous truck engine with its PCV system. We've got one of our PCVs right here. Goes into our actual plenum of our intake, and then our other one goes from right here of our valve cover straight into our intake manifold, but after the throttle blade. So it's not as leaky, and so we're gonna look at it real quick. So now we're gonna pull off this. See right here. Pull this off, and see it's very oily right there and there. And that's a common issue with the Gen 3 5.0s. They have very good vacuum from revving down from high RPM. They end up pulling that oil from the camshafts right here, the valve train, and pulling it into the intake. So this is a common issue with the PCV. All right, so now we actually pulled it. So now we're gonna see. Got a very big vacuum here. So, pull that vacuum. There we go. Everybody's back. There we go. All right, so now we're gonna talk a little bit about the PCV system. You know, I kind of gave a little diagram right here. So there's our V8 engine that we just saw, Coyote, and we had a PCV line from the valve cover all the way into the intake after the throttle plate, and then we had another one on the driver's side that went into the just MAF air filter right here, but before the throttle plate. So I'm kind of explaining the difference between the two. So between this one and this one, there's going to be pretty much constant vacuum until wide open throttle. And so that's just kind of draw all of the blow-by air that is created by these pistons. So air is going to come by from those piston rings. It's going to settle inside the crankcase. Except you don't want that, because that'll create a high pressure and eventually start shooting out there or outside. It's going to come through there, or it's going to come out through there. And it's going to create heat, and that's no good. So we need to get rid of it. And there's also a bunch of hydrocarbons and CO that get past those rings. And we can use that. So we actually draw it in, and it goes before the throttle plate, and there's a constant vacuum going through there. Now this other one is to replenish with good clean air. So you do it after the filter, but before the throttle plate. That way air is actually being drawn from here into the actual valve cover assembly. That way you have bad air coming in, all the hydrocarbons coming in most of the time, and then you have good air to replenish it. There should be a slight vacuum at all times, just because this is greater than this pressure. And so that was the test that we saw. We covered this one, we pushed our finger on it, and we saw that it worked very well, and that's how PCV systems work. All right, we got a 97 Chevy Tahoe right here. It's got the 5.7, and now we're gonna locate the EGR. And the EGR is actually a linear solenoid right here. It's got our different connectors, our positive, negative, ground, and then our signals. And that connects right into the actual intake to allow air to flow back into the intake from exhaust. Yeah. All right, we got a 1998 Honda Odyssey, and we got the 3.8 liter V6 it's pretty dusty in here. And then here is our EGR. It's a little dusty. This is why it's decommissioned. We're also missing 2 spark plugs and oil. So just taking a look at locations for these cars. All right, we got a 2005 Chevy Trailblazer LT, and it's got the Vortec 4200s, the inline 6 right here. And if we move our way around to the exhaust side, we can see the if we get rid of this cobweb, we can see the EGR right here. This is our EGR solenoid, and it goes right back. Looks to be a linear solenoid, very common. So let's find a different one that's not linear solenoid. All right, we got a 2014 Nissan GTR R35 twin turbo V6, and the EGRs are actually located behind the intake, right back here. Let's see if we can get a good angle at it. It's actually that canister right back there. See, that can right there. So this right here, that's one of the EGRs. There are actually 2. The other one's located back underneath all this piping, and helps with the boost control and reducing NOx emissions. All right, we got our last vehicle, Acura RL. Came with the 3.5. It's from 1997. So we got the Honda Motor Corporation right there. So if you sit at the front of the vehicle, we got 3.5. Beautiful. You come around to the passenger side, and you look under these hoses, right there. This thing right here, your EGR system right there. It's a little rusted, needs replacement. All right, next we're going to talk about EGR systems. So we have our intake valley, our piston inside our block and our valve cover, and then our exhaust manifold with our EGR solenoid is going to be a linear solenoid, and then to our cat and to our exhaust. So first, air is getting drawn in, it explodes. We're doing this, let's say we're at idle conditions, so the EGR will be open. The piston explodes, it comes out, it goes through the EGR, which is open, and it will let a large amount of exhaust to come back in. And now you're thinking, why would you want to do that? There's nothing that's good in there, except there is. There's good things that we actually want. There are good things that are bad for the cat, that we want to save, and also bad for the environment, because we care about the environment. So we want to reduce nitrous oxide gases due to high combustion temps. From that high idle, it's going to be pretty hot inside that combustion chamber. And so that causes a lot of chemical imbalances and a lot of heat to burn on one side and cause nitrous oxides, which is really bad for the environment. And also we want to reduce our hydrocarbons and CO, which is also a byproduct of incomplete combustion. And so what we do is we recycle that bad air back into the intake. We still shoot new flames and we shoot more fuel into it, but it also will reduce hydrocarbons and NOx, which will save the environment and will save your cats. So that's kind of why we do it. It opens up the diverter valve and it goes back right into it using the vacuum from here. And then this is normally controlled by PCM. As you saw, we saw those wires that would come off. You would see solenoids. Usually it's about 3 to 4 wires that'll go into your PCM. And so that's really how it's controlled. And so it's a new thing required by the EPA, and it's very good for the environment, and that's pretty much how it works.